right, so we're talking really here about something that is new. It is the power rule. And again, we want to actually start with some graphs. So I'm going to make these a little bit smaller. Again, we're talking about position versus time here. And let's say that we have a graph that looks like this. So x equals 3. Well, again, if we wanted to take the derivative of this, all right, which is just the slope, okay, let's make a little chart over here and we'll keep track of all these different things. So the x position, or you could say that the position function with respect to time, okay, this is the actual function for position as it relates to time. We're going to look at some different examples. And I could make that line a little straighter. Let's look at the derivative now, dx dt. All right, dx dt, the derivative of these individual functions. Okay, this can also, you could see this as x prime t. So if you have a function related to time, in this case position versus time, x prime is another way of saying the first derivative. We'll talk more about it, but I'm just giving you some exposure to it. All right, so back to this example here. Well, so what is our actual function? Well, our function is 3. And well, what's the slope of a 3? X equals 3. Well, the slope is 0. But does it really matter what the number is? I mean, if I had a slope of, a function that said x equals -3 or x equals 1, it really doesn't matter. What we're seeing here is that any constant, I'm just going to call it c, is going to return a derivative or has a slope of 0. So this is called the constant rule. All right, so anytime you have a constant, you're taking a derivative of it, it is going to be 0. All right, well, that's good. Let's look at if we have a linear function, what do we get? All right, so let's say we got x versus t again here. And, well, that's almost like a one-to-one relationship there. So let's say that this is, so x equals t. Okay, x equals t. Well, if x equals t, what do we get? The slope is 1. Put in 1, I get 1. I put in 2, I get 2. So the slope or the change is 1 to 1. So for t, we get a value of 1. Well, what if it's, let's say that this is x equals 3t. Well, again, you're starting to see this y equals mx, mx plus b format. Okay, y being the vertical variable that we're on our graph here. So the slope is just m, is 3. So if we have 3t, we know the slope is 3. All right, we're starting to see some pattern here. Whenever it's just t, I get 1, and if there's a value or a constant in front of it, this still carries on. All right, we're not fully there yet. Let's take a look at parabolic function. All right, get back to where we were looking with our graph here that says, let's talk about x equals t squared. All right, x equals t squared. Well, we actually went through using the limit rule, okay, for this x equals t squared, and we found that the derivative or the slope as it relates to time would be 2t. So if we have t squared, we actually get 2t. Well, let's see here. Let's take a look at another one here. If we look at what if we let's say we moved it down. How about, let's take another look. Black here, again, we are position versus time. And let's say we are, and this function here, x is, let's say it is 3t, excuse me, t cubed plus 2. Okay, t cubed plus 2. T cubed plus 2. Well, it turns out that this 3 is going to come down here, so we have 3t squared, and then this 2 is a constant, it goes to 0, so we're just left with 3t squared. So, without spending too much time belaboring this, what this really comes down to, the power rule, as it's given to us on our equation sheet, our physics equation sheet, okay, is going to be, let's write it out over here. So our function in this case would be, let's say, any variable x to some power. Again, we're talking about the power rule. So any variable to the nth power. If I want to find the derivative of this function, I take this value of the exponent and then bring it down and multiply the overall function to it. So it becomes n times the variable. And then I'm going to take 1 away from this, so this becomes n minus 1. So from a power rule standpoint, what we're saying is that the derivative, okay, with respect to x, any variable. Now here we've been working on the derivative of position with respect to time, but the derivative of any function x to the nth power with respect to x is going to equal n x to the nth minus 1 power. So this is the power rule. This is the equation that we will be using as we take our derivatives. So let's just look at a couple quick examples here and see if we can, let's see if we can find what would, let's see, 3t plus 4. So 3t plus 4, how would we find the derivative here using the power rule? Well, 3t is just 3, right? So this is really like t to the first power. So if I take 1 and I multiply that down, following our function here, this gives me 3, and then t to the 1 minus 1 is like t to the 0. Well, t to the 0, anything to the 0 power is just 1, which is why we end up with 3. 3 times 1 is 3. So 3t just becomes 1. Excuse me. It just becomes 3. What am I saying? It just becomes 3. And then plus 4 is a constant. So the constant becomes 0. So the slope of 3t plus 4 is just 3. And this is a linear function. This happens to be the y-intercept in that case. All right, well, let's look at 4t squared plus 2t. 4t squared plus 2t. All right, power rule says take the exponent, multiply it down. Well, 2 times 4 is 8. 2 minus 1 becomes t to the first power, so that remains, plus 2t. Well, it's just like what we did up here, so this is really just plus 2. So this is the derivative. This is the velocity function as it relates to this position function. So if I want to find any instantaneous velocity with respect to time, I just plug time into this equation here. This is the velocity function. All right, one more here. If we can still see here, let's try 2t cubed plus 4t plus 8. All right, so 3 comes down, becomes 6t. 3 minus 1 is 2, so 6t squared plus 4, constant 8 becomes 0, and this is my velocity function. All right, last thing I want to say right here, just as a quick wrap up of this, okay, we're talking about the derivative function, and specifically as it relates to physics, okay, Okay, we have the position function, and then we have velocity, we have acceleration, and what we're saying is if I take the derivative of the position function, I get velocity. If I take the derivative of the velocity function, I get the acceleration function. And it actually goes on from there. You take the derivative of acceleration, you get what's called jerk. If you take the derivative of that, you get something that's called snap. Take another derivative, you get crackle. And you guessed it, snap, crackle, pop. So we would say that the first derivative is velocity of the position function. Second derivative would be acceleration. The third derivative, and so on, so on, so on from there. Okay? So if I take the derivative of the position function, I'm going to get velocity. All right, thanks, guys.